Now we're doing problem 6. So problem 6 reads, let f of x equal x minus 1 divided by x squared, given that f prime of x equals 2 minus x divided by x cubed, and f double prime of x equals 2x minus x divided by x to the fourth, then which of the following statements is or are true for f of x? So these are the statements. Your first statement A says the limit as x approaches 0 from the right of f of x is equal to negative infinity. Your second statement, B, says the graph of f of x has no horizontal asymptotes. The third statement, C, states f of x has a critical point at x equals 2 only. And the fourth statement, D, states according to the second derivative test, f of x has a vertical maximum at x equals 2. So let's go down the line and see which are true and which are not true. So for A, the limit as x approaches 0 from the right of f of x is equal to that. So here's f of x. If I go ahead and plug in a small number, so if I'm approaching from the right, 0 from the right, I'm going to plug in a small number. Let x be, let's say, 0.01. Okay? If I plug that in here then, I get that f of 0.01 is equal to 0.01 minus 1 divided by 0.01 squared. Okay? And what do I get? I get 0.99 minus 0.99 divided by, okay, I get 0.101 squared, that's 0.0001. So that's fairly a big number compared to 0.001. So that's like kind of 1 divided by 0, but 1 divided by 0 is a very, very big number. So that would be infinity. So that would be infinity, but it would be a negative infinity. So if you try this for multiple x's as they get closer and closer to 0 from the right, you're going to get a very, very, very big number. And a minus at that, because you're going to get a minus here. So that's going to be minus infinity. So this is true. So A is true. So A, that's true. Yeah. So that one's true. Alright, B. So let's look at B. Alright, B says the graph of f of x has no horizontal asymptotes. Okay, so is this true? So we look at f of x. In order to find the horizontal asymptote, we take the highest degree of the numerator and we divide it by the highest degree of the denominator. Okay, so we get x divided by x squared. That gives us 1 over x. But 1 over x, if you take the limit as it goes to infinity and negative infinity, this is always equal to 0. So there is a horizontal asymptote, and that's exactly at y equals 0. So this statement is false. The graph of x has no, it does have a horizontal asymptote, and it's 0. We found it. So that's false. Okay? Let me move this over here. So y is equal to 0. So that's our horizontal asymptote. Alright, let's go to C. Alright, so C says f of x has a critical point at x equals 2 only. Alright, right over here I recalled some the idea of critical points. So for critical points, the possible critical points are x values that make the derivative equal to 0 or undefined. But if the function is not defined at that x value, at those possible critical points that you found, then it is not a critical point. So when we go ahead and equate the first derivative, or the derivative, and we equate it to 0, and we also equate it when it's undefined, so we make the numerator and denominator equal to 0, we have to go ahead and plug in those x values, those possible critical points, back into the original function. And if one of those critical values does not work, then it's not a critical point. And the other rest that do work are critical points. So let's go ahead and make the first derivative equal to 0. So when the first derivative is equal to 0, that means the numerator is equal to 0. So set 2 minus x equal to 0. And when it's undefined is when the denominator is equal to 0. So set x cubed equal to 0. So if you do that, we obtain that x is equal to 2. And we obtain that x is equal to 0. So these are possible. So possible. possible critical points. They're not critical points yet. In order to find out if they're critical points, we need to evaluate them in the function to see if they're defined. So f of 2. Is f of 2 defined? That's 2 minus 1 is 1 divided by 4. So it is defined. What about f of 0? Is f of 0 defined? Nope, because we have 0 squared here in the denominator, we can't have that. So f of 0 is not defined. Therefore, the only critical point is x equals 2. So, therefore, only, I'm going to put CP as critical point, is x equals 2. So that is true. Therefore, C is true. Alright. So now we look at D. Okay. So for D, second derivative test, f of x has a relative maximum at x equals 2. Alright, so what I like doing here is, we already have a critical point, x equals 2, right? So if you go ahead and draw a number line, and put your only critical point, or in this case we only have one, but if you had 2 or 3, put them all on the number line. And then what you want to do is grab test points. So let's say I grab a test point here of 1, and a test point here of 3. Alright. So what I'm going to do with these test points, and I'm going to go ahead and plug them in to the first derivative. So plug them in here. So I want to find f prime of 1. So f prime of 1 is 2 minus 1, that's 1. And that's, pretty much we're just looking for signs here. So it's going to be positive, right? So we're going to have 1 cubed 1, that's 1. So this is pretty much increasing. So from negative infinity to 2, it's increasing. Let's find f prime at 3. Alright, so f prime at 3 is what? 2 minus 3, that's minus 1, divided by 3 cubed. So this whole thing is a negative number. So that's going down. Alright, so what does that mean? In order for this graph to go up and then come down, so to increase and decrease, that means there's got to be a maximum point here where the graph does this. Therefore, there is a relative maximum at x equals 2. So then D is true. Okay? So therefore A, C, and D are true. B is the only false one.